Question number 9 refers to parametric equations. Find the maximum value of C. Well, I notice that C is the largest t value, and any t can go into there, but the only t's that can go into there, that an inverse sine goes from -1 to 1. Therefore, t on 10 has to go from -1 to 1, which means t would go from -10 up to 10. Since I've got a restriction at 0 at one end, c has to equal 10. Okay, find the speed of the particle at the point where it's the furthest distance from the x-axis. So the point where it's the furthest distance from the x-axis will be when the j component of velocity equals 0. That's when it will be the furthest away from the x-axis. So I need the velocity. So this is position. So I need to take the derivative of this. So r dot of t is going to equal 3. The derivative of sine is 1 on top of the square root of 1 squared minus t on 10 squared times 1 on 10 in the I, minus, I've got a product rule here, so I've got the derivative of t is 1, so that's e to the minus t, then minus t times the derivative of this, which is e to the minus t times minus 1, so that becomes a plus, and that becomes in the j. And this is going to be 3, 1 on top of the square root of 100 minus t squared times 1/10 times 1/10. So those 1/10 will cancel, and that will be 3 on top of the square root of 100 t squared. Okay, so that planes up to give me that. So this is the velocity. It will be the maximum away from the x-axis when this is equal to 0. So minus e to the minus t plus t e to the minus t equals 0. I'll take out a e to the minus t minus 1 plus t equals 0. That's when t equals 1. And when t equals 1, that will be 0, so that the speed at 1 will equal 3 on top of the square root of 99. I could square it and take the square root, but it's just going to be that, which will be 3 on top of 3 root 11, 1 on root 11, or root 11 on 11 meters per second. I'll take that, or that, or that as an answer. Okay, that's part B. Part C, the magnitude of the initial acceleration. So the magnitude of the initial acceleration, so I need to find the acceleration, and the acceleration will be the second derivative of time. So I've taken the first derivative of time, and I've got this expression. So I'll get a copy of that. And I'm looking for the derivative of this. So paste. So I'm looking for d dt of this. So I've got effectively 3 100 minus t squared to the half negative in the I. So the derivative of that will equal, so a of t should equal 3 times negative a half times 100 minus t squared derivative minus 3 on 2 times 2t, all in the I. I've got the derivative of this, which is positive e to the minus t, plus the derivative of t is 1, so e to the minus t, then minus t e to the minus t in the j. And I'm looking for the initial, so a of 0 should equal, well, since I've got a 0 here, all of that is 0 in the I, plus e to the 0 plus e to the 0 minus 0, 1 plus 1, the acceleration due 2 meters per second squared.